So good morning children. Hope you're all good. Okay. So had a very good break of 5 days. So hoping that you must have completed all your pending works. Fine. So did we stop? We were with the chapter periodic classifications and we discussed about two important laws. One was the Doberanus triad and the other was the Newland's law of octaves. So now today we'll discuss about the next attempt made in the periodic classification of the element, that is by Mendeleeves. Okay, so we'll talk about today Mendeleev's periodic table. So before we move to Mendeleev's periodic table, just let us have a recap of Newland's law of octaves. So as we discussed, though there were some limitations, there was one major achievement of Newland. What was it? He could arrange the elements in a tabular pattern, and he observed some common properties being repeated at regular intervals, which we call it as what? A periodicity. So arrangement of elements in the increasing order of atomic masses, and then occurrence of the properties at regular intervals, that is nothing but periodicity, were the three major achievements of whose Newland. Am I clear? So these achievements of Newland were taken forward by other scientists, and one prominent among them was Mendeleev, a Russian scientist, okay, a Russian chemist. Now what he did, he took up the limitations of Newland's and he improved or improvised on them. Thereby, he formulated or he constructed his own periodic table. Now, before we go to Mendeleev's periodic table, we will just discuss about what were the criteria which Mendeleev took in order to design his periodic table. Now, as his earlier predecessors, he also took the first criteria as what? Atomic mass. So, what was the first criteria of Mendeleev? First was atomic mass. Then, adding to this property, this criteria, he also took some of the other chemical properties also as a criteria, which was not taken by any scientist so far. So first was the increasing order of the atomic masses and the other was the chemical properties. Clear? So by keeping these two into consideration, Mendeleev derived or constructed his own table. Now how did he construct the table? He constructed his table into vertical columns, okay, and then horizontal rows. So as like Newland only, he also constructed into columns and tables. But he had in his periodic table, when he constructed, he called this vertical columns as groups. What did he call them as? Groups. And the horizontal rows, he called them as periods. So now he coined two terms. We can say one was the groups and the other is periods. So where periods were the horizontal rows, okay, and groups were vertical columns. So Mendeleev's table had total of 7 periods. Okay, he had how many periods in his? There were how many? 7 periods. And how many groups were there? 8 groups. Clear? Okay, now the question comes, how did he start arranging the elements? Now, what he did before he constructed his table, at that time, by the time Mendeleev constructed his table, there were almost 63 elements which were known at that time. So he took all these 63 elements and he designed each card for each element. Okay, so like your playing cards, he designed cards, 63 cards, mentioning on each card the name of the element. Okay, so the name of the element was mentioned, the symbol was written, the symbol, then the atomic mass, the atomic number, and some of its properties. Clear? So like this, he constructed 63 cards. Now as he kept on arranging them in the increasing order of their atomic masses, he observed that some chemical properties were repeated at regular intervals. Followed. So this, he observed that there were some repetitions going on, like as proposed by Newland. So what he did, he kept this in mind, and along the periods, he arranged the elements in the increasing order of atomic masses, and once when he saw that a property is getting repeated, that particular element he placed very immediately next below the previous element. So the elements in a group had similar properties. What were they having? They were having similar properties. So who had similar properties? Elements in a group. And along the period, they were just arranged in the increasing order of atomic masses, thereby giving rise to different properties. Followed? So the first criteria was considered. Now coming to the second criteria. What was the second criteria? Second criteria was the chemical property. The question comes, what is that chemical property which Mendel took for his study? He mainly took two chemical properties. One, the reaction with oxygen, and the reaction with hydrogen. So he studied the chemical properties of the compounds formed when they react with oxygen and when they react with hydrogen. So any element, when it reacts with oxygen, it forms oxide. You all are aware of it. Similarly, any element, when they react with hydrogen, they form compounds called as hydrides. Followed? Okay. So now what he did is he started observing the chemical properties. Now the question comes, how did he study them? Now you all have learned in chapter 1 regarding the chemical formula, isn't it? So what is a chemical formula? Chemical formula is the combining capacity, as you all have learned. So suppose if I take up sodium chloride, let us take up sodium oxide. So what is the formula of sodium oxide? Na2O. Similarly, let us take up calcium oxide, CaO. So now, if you see now how is the combination in sodium oxide? Two sodium atoms combining with one oxygen atom. Clear? Now, similarly, as like sodium, potassium also will react with oxygen to form a compound called as potassium oxide with a formula same to that of sodium oxide. So K2O. In the same manner, here as well, like how one calcium atom is combining with oxygen to form calcium oxide, similarly one atom of a magnesium will combine with oxygen to form magnesium oxide. Now tell me, what is a common feature of these two? They have a same formula. So if I take up, let me consider Na and K as represented as R. Okay. And then how many R's are combining? 2. With how many oxygens? 1. So my general formula for sodium and potassium will be what? R2O. Similarly, if I have to consider calcium and magnesium, same as in case of sodium and potassium. So but here, what is their common formula? RO. So that means, since the formula, they have a common general formula, their chemical properties also will be similar. Okay. So sodium oxide and potassium oxide will be similar in their chemical properties as they have similar chemical formula. Same will be calcium and magnesium as well. And now this was with whom? This was with oxides. Now let us take example with whom? With the hydride. Now in the same way as in case of oxygen, even when they react with hydrogen. So we will go with the same example. So when sodium reacts with hydrogen, it is NaH. Similarly, when they react with potassium, it is potassium hydride. Okay. So now if you see, their formula will be what now? They will be having a general formula of RH. Okay. So what does it mean? That one element of sodium and potassium will combine with one hydrogen atom. Okay. So in the same manner here as well. If I have to take up, if I just construct, so their general formula will be what? RH2. Okay. So general formula, what does the word general formula means? Means the elements of this particular group will have a common formula. That means whatever may be the element, they will be forming the compound with the same formula. And if they have a same formula, similar formula, definitely their chemical properties also will be similar. Then the one more question, why did he choose only oxide and hydride? Why not other compounds? We all know because oxide and oxygen and hydrogen are the most abundant. The compound, these are, since oxygen and hydrogen are available in abundance, elements also react very often with oxygen and hydrogen due to their high reactive nature. So these compounds are found very commonly in the nature. Hence, this was taken as another criteria by Mendeleev to study the chemical properties and to arrange them in a particular systematic manner. I hope you must have understood this, children. So we have discussed that what were the criteria. One was increasing order of atomic masses, and the other was what, the chemical properties. And which chemical properties? Oxides and hydrides. So thereby he came to a conclusion to give his law. So what was the law? The law stated that the chemical and the physical properties, what properties? Chemical and physical properties of an element are periodic functions of atomic mass, of their atomic mass. So this was the law which was proposed by whom? By Mendeleev. So what did he say? That the properties of the chemical and the physical properties of an element are periodic functions of atomic mass. Periodic function means the arrangement in a regular pattern. Okay. So with this we have completed the introduction of the Mendeleev's periodic table, children. So in the coming class we will be discussing about what were his achievements and what were his limitations. Please kindly go through the textbook. Thank you.